This course is divided into 3 parts or 3 sections. So let's get started. First of all, let's see what is there for you in the first part of this course. So we will start with mobile device vulnerabilities that are categorized by OWASP organization. Then you will learn how difficult it is for enterprises to protect their infrastructure when their employees bring their own devices to work. We have also covered an introduction to mobile device management and mobile device security policies. In the next part, we will start with Android security structure, and then we will explore what Android emulators are. And then we will learn about Android hacking tools and techniques. And in the last section of this course, we will start with iOS security, how to jailbreak iOS devices and how to disassemble iOS applications. That's it for this lecture. Hope to see you in the first section. This is the first lecture of part 1. I hope you all know about an organization called OWASP. If you are not familiar with this organization, I'll explain to you right now. So, the Open Web Application Security Project or OWASP is an online community that produces freely available articles, methodologies, documentation, tools and technologies in the field of web application security. OWASP is also registered as a non-profit organization in Belgium under the name of OWASP Europe VZW, and for more details visit their website www.owasp.org. Now OWASP passed an initiative called the OWASP Mobile Security Project, and it is a centralized resource aimed to give developers and security teams the resources actually need to build and maintain secure mobile applications. And of course, extends more than the mobile applications, but they actually are focusing in this specific initiative around mobile devices and mobile applications right now through the project. Their goal is actually to classify mobile security risk and provide developmental controls to be able to reduce the impact or the actual likelihood of exploitation of vulnerabilities in mobile devices. Now their primary focus is at the application layer. They also take into consideration the underlying mobile platform. So the actual hardware itself and also even the service provider risk whenever they are doing that threat modeling and building controls, right? Now they also cover not only the mobile applications deployed in the end user devices, but also the broader server side infrastructure, and which is actually the mobile applications will communicate to. So in a lot of cases, actually these mobile applications are communicating to the cloud, right? So they also look at that communication from the mobile device and the cloud environment. They also cover best practices and vulnerabilities around the integration between the mobile application, the remote authentication servers, and the actual cloud platform specific features. Okay. Now let's take a look at some of the top security vulnerabilities and threats that are assessed for mobile devices in their website. If you look at the OWASP Mobile Security Project website, you will find tons of resources related to mobile security. So the website includes the top 10 mobile risks, and we will review those in a minute. So now it also includes mobile security checklist, a mobile security testing guide, a set of tools that they actually call M tools that allows you to test the security of mobile devices, a guidance for secure mobile device development, and also the top 10 mobile controls, and a project that is dedicated to teach you how to perform threat models for mobile devices. Now if you click on the top 10 mobile risk, you will see that the current top 10 vulnerability or risk types for mobile devices are the following. And number 1 is improper platform usage. Then insecure data storage. Next is insecure communication. Then insecure authentication. Next is insufficient cryptography. And this is actually one of the challenges nowadays, because a lot of people should trying to create their own crypto implementation. Okay. So whenever you do that and you don't reuse some of the stronger out there like OpenSSL and some other ones that actually a lot more maintainers actually contribute to them, you will introduce security problems for sure, right? So the other ones, it's not only as far as the actual core crypto components, but also the implementations of those, right? So especially whenever you actually do not have a sufficient cryptography best practices including to your device, right? Next is insecure authorization. Another one is client code quality, code tampering, reverse engineering, and extraneous functionality as well. Now this change from time to time, okay? So I definitely recommend for you to do two things. Keep these resources handy and also subscribe to their mailing list to get information about any new threats and maybe you can even contribute to the project personally. And these guys actually not only provide a lot of resources for mobile device security, but a lot of resources and tools are also shared on their website. In this lecture, we will talk about BYOD. So what is BYOD? It stands for Bring Your Own Device. It is a trend that is quickly expanding, in which companies allow their workers to bring their own personal devices to work and connect to the company's resources. That way, employees can work with their personal computer, can focus all the information in their personal phone, or have access to the corporate web from home. Now, BYOD is not just walking around the office with your personal devices, it has a lot more implications for the organization and working process. Before, you sure the companies were better equipped than users. For example, normally people didn't have a personal computer at home, but they did in the company. And usually if you had a mobile device, it belonged to the company. However, advances in technology and consumerism have made it so that nowadays users have a more advanced technology than even what their company gives them. This has caused a huge growth in BYOD all around the globe and in big and small enterprises. The main pros of BYOD are the productivity and satisfaction in the workers increase. This is due to the fact that they use their own devices and applications and feel more comfortable. Also, they can work with more flexibility, choosing when and where, since the device is with them constantly. The company also saves a lot of money in technological resources. However, this all brings the main disadvantage of BYOD, which is security. The company's information is at risk. For example, if an employee loses his phone or a malware infects a device, this requires bigger maintenance and control from the IT department and a bigger cost of web data. To avoid this, it's important to have a mobile device management. These are programs that allow you to guarantee the security and install remote applications, synchronize files, or track devices. They include many features that protect the privacy of the company. Therefore, BYOD is a great trend that is quickly becoming more and more popular. However, we must not forget to take the necessary security measures to use it. As you all know that the use of mobile devices has skyrocketed in the last few years and the trend is growing. According to IDC, the smartphone market is already larger than the PC market, which leads to mobile device management or MDM. So what is MDM? It's an ability to manage any device. So it can be a phone, it can be a tablet, or it can be even a laptop. Any mobile device from a central location, right? So example of that is Cisco Meraki and other companies that actually provides a central policy enforcement and management of these devices. And basically the goal is actually to protect those devices not only by providing patches but also by providing policies from your central location. Like in this case, it is Meraki in the cloud, right? So from cloud, you can manage devices within your organization, perhaps not installing the application and maybe that device camera enable. So you can actually specify the policies on how you want to manage those devices. Additionally, some of these devices are actually talk to other devices in the network, like the ICE or Identity Service Engine to enforce further policies. Let's say you have an unmanaged tablet. Perhaps actually you don't want this tablet to accessing to a server in your organization. So there is policy that can be sent to a switch or firewall to actually block tablet from connecting to sensitive data or sensitive systems of your company, and then allow tablet to actually connect to the internet or vice versa. This tablet only connects to some resources and it would not connect to the internet, right? So possibilities are endless. You can modify policies to block some applications or allow some content to transfer to internet or to communicate any other devices within the organization. So that's one of the things that we are doing a pen testing. You actually have to keep in mind that some of these devices that you may actually be able to enumerate whenever you do reconnaissance on the network, or either you are scanning and that perhaps are actually vulnerable to something. They may actually be managed by an MDM. So try to actually find ways that you can bypass or even block the communication between the MDM and the mobile device, right? So of course, that's easier said than done. But there may be ways that you can analyze the communication of that device is actually allowed to do or not to do, right? So you can actually do this by actually monitoring the device activity, or perhaps you say, okay, this device perhaps is actually communicating that I am seeing these type of transactions to some API in the internet, and this MDM is actually allowing that to happen. So now you actually have a footprint, and if an attack surface, that you can actually further explore. So for example, if that API perhaps is actually doing with crypto, you probably can take advantage of a vulnerability to hijack that transaction, for example, or an API abuse vulnerability that may actually be irrelevant in that case. But always keep in mind that a lot of organizations now are actually using MDM to actually manage those devices, monitor them, and also patch them, right? So it's getting a little harder to actually do some of the bypasses nowadays, but definitely is possible. Now actually not only looked at the infrastructure here, but what the devices are actually communicating outside of the company as well. In this lecture, we will talk about Android security structure, and explaining Android security structure is a bit longer. So I have divided this lecture into 3 parts, and this is part 1. So let's start. Google actually inputs security features and work with developers and device implementers to keep the Android platform and the ecosystem in a safe environment. And again, it's not so much only about the actual Android platforms or your mobile device or your tablet or your refrigerator, whatever the case is actually running Android, but also as far as actually ecosystem, right? How you are connecting to the app stores, how you interact with APIs, and so on. Now the beauty is that Android is designed to be open, and one of the challenges is that it has a little less controlled when compared to the other alternatives like Apple iOS. Now Google tries to maintain the Android platform to offer an application environment to help protect the confidentiality, integrity, and availability of users, and also of the data and the applications and the actual device itself, and of course the ecosystem as well. Now both Apple and Google have dedicated a lot of resources to make their mobile operating systems fairly secure. Some of the main challenges in security is whenever users root their device or jailbreaking the devices and leaving them open to either malware or compromised applications. Okay. Now the main Android platform building blocks are of course the device hardware, right? That runs on the terms of hardwares. So that includes your smartphone, your tablet, your smartwatches, cars, smart TVs, gaming systems, etc. A lot of things actually run Android nowadays. Now the other beauty is that Android is process or agnostic, right? But it does take advantage of some of the hardware specific security capabilities, especially in the ARM architecture. Okay? And there's actually a security capability called ARM execute never, right? There prevents a remote execution or arbitrary execution of any type of buffer overflows, perhaps that actually can be exploited in the system. Okay? Now the Android operating system is the core operating system, and it's actually built on top of the Linux kernel. So it's all based on Linux. All device resources like the camera, Wi-Fi, Bluetooth, GPS, telephony functions, the network connectivity, etc. are accessed via the operating system itself. Okay. Now you also have the Android application runtime. Android applications are actually most often written in Java programming language, and they actually run in the Android runtime, right? And they refer this as the ART. However, many applications including the core Android services and other applications are actually native applications or include native libraries within the operating system itself. Now the Android applications extend the core Android operating system, and there are 2 primary sources for these applications. Okay? So the first is pre-installed applications that come with your device, and second is the user installed applications via the Google Play or any other stores that can be accessed mostly if you root the device. And that leads to the problem with security as I mentioned before. Welcome to part 2 of Android security structure. As you know, Google provides a set of cloud-based services that are available to different compatible Android devices. And these services are not part of the Android open source project itself, but they are included in too many different Android devices, right? So we have the primary service for installing applications from the actual store, which is Google Play. And you also have the services to actually push updates, which is called Android Updates. Android Updates is an update service that provides new features and security updates through either the web or through over the air. Okay. So now there's also the application services, and basically it's a framework that allows Android applications to use cloud capabilities like backing up your application data, backing up your settings, and also they have cloud to device messaging that is called C2DM. C2DM is used for pushing messaging to the cloud as well. Okay. They also have another service called Verify Apps, and it basically warn you or automatically block the installation of any type of a compromised applications or any harmful applications, and also it continuously scan applications on the device and warn you about them or removing those applications automatically. Another service is the safety net. Now some of you may be thinking that why I am explaining these terms to you. Well, because it helps you whenever you are doing pen testing. Okay. So now going back to the services, safety net is basically a privacy preserving. Well, some people call it intrusion detection system to assist Google tracking and mitigating known security threats, and also to identify other type of abnormal activity within the Android ecosystem. Okay. And now part of that is the safety net attestation service. And it basically allows third-party APIs to determine whether the device is CTS compatible and also can assist identify the Android app communicating with the app server, right? Now there's also the device manager. So the Android device manager is a web app and also an Android app that is actually used to locate lost or stolen devices, which is similar to what Apple has with Find My Device function. Now the Android security model is actually based on the concept of application sandboxes, okay? And each application runs its own sandbox. Now a long time ago, I mean several years ago, prior to Android version 4.3, these sandboxes were defined by the creation of a unique Linux UID. And the UID was actually for each application at the time of installation. Now from version 4.3, Android actually uses SE Linux, that is the security enhanced Linux, and it is actually used for defining the boundaries of the application sandbox in Android. Okay. Now as part of the Android security model, Android uses SE Linux to enforce MAC, that is mandatory access control over all processes, right? Even processes running with root or super privileges or super user privileges. And this actually helps protect the operating system. Also, SE Linux enhances Android by confining privilege processes and automating the security policy creation on that device. Now, Android also includes SE Linux in enforcing mode, and it is basically a corresponding security policy that works by default across those devices, right? So now in enforcing mode, whenever you do security research in Android platforms, the illegitimate actions are prevented by default and attempted violations are actually logged by the kernel to demessage and to logcat. Okay. Android devices manufacturers should actually gather information about these errors so they can actually refine their software and their own SE Linux processes before enforcing them. However, unfortunately this doesn't happen all the time. Okay. That's one of the major differences between Apple iOS devices and Android. Although Google provides the operating system to Android, but it's up to the implementers to actually take care of these acute implementations, and maybe some implementations may be more secure than others. Now by default on Android, only the kernel and a small subset of the core applications run with their permissions, right? Now Android does not prevent a user or an application with root permissions from modifying the operating system, okay? You can also modify the kernel or any of their application. So in general, root has full access to all applications and all application data. So whenever users change their permissions on an Android device to grant root access to applications, definitely it increases the security exposure to malicious applications and potential application flaws. And that's whenever you see a lot of impersonated applications and so on. So again, a lot of people that actually root their devices has to keep in mind that whenever you are doing security research on Android devices, in a lot of cases actually what people do is they start from just by rooting a device. Now the ability to modify an Android device that you own, it's important developers working with the Android platform, right? So on many Android devices, users actually have the capability or the ability to unlock the bootloader in order to allow the installation of some other alternate operating system. So some will call it custom ROMs, right? And these alternate operating systems may actually allow a user to gain root access for the purpose of debugging. and then system components to access the features that are not present to applications by the Android APIs by default. Okay. Welcome to the third part of Android security structure. In this lecture, we will talk about encryption, and it's specifically encryption at rest, right? Now Android version 5.0 and later, so for quite some time they actually supports full disk encryption. And then from Android 7.0 and later it actually supports file-based encryption as well. And basically file-based encryption allows different files to be encrypted with different keys that can be used to decrypt or decrypted or unlocked independently. Okay. Another thing that I want to cover here is the application signing. So application signing allows developers to identify the author of the application so that the user knows that the application is actually legitimate, and also to update their application without creating complicated interfaces or permissions, right? Now every application that is run on the Android platform by default must be signed by the developer. So if you root it and you go to some other stores, that's definitely a very different applications that actually attempt to install without being signed by default are rejected by either Google Play or the package installer on the Android device. Now on Google Play, developers know their application. It's actually provided by them or modified by them, and the developers actually can be held accountable for the behavior of the application. But of course, if it's modified, then all bets are off, right? Now on Android, application signing is the first step to placing an application in its application sandbox. Okay. The sign application certificates define which user ID is actually associated with which applications, and then different applications run under different user IDs. Now application signing ensures that one application cannot access another application except through a well-defined IPC. Now when an application or APK files, basically applications are APK files, whenever these are installed on an Android device, the package manager is the entity that actually verifies that the APK has been properly signed on with the certificate included in the APK. If the certificate, or more accurately the actual public key in a certificate, matches the key that is actually used to sign any other APK in a device, then new APK actually has the option to specify the manifest that it will actually share a user ID with other similarly signed APKs, right? Now applications can be signed by third-party OEM or any other type of marketplaces. In a lot of cases, actually some enterprises may have their own app, so they have a different market, okay? It's not only because the device has been rooted and you want to get a free game from some other market, but in some cases actually there are some legitimate stores that are alternate markets that applications actually need to be signed, and those are actually signed with a third party or self-signed certificate. Now applications do not have to be signed by a central authority, and Android currently does not perform any certificate authority verification for application certificates. And that can be actually huge in the case of security, because it may actually lead to a security compromise if you don't verify the CA verification. Of course, it's a little bit different to scale whenever you provide the operating system and you have many different implementers in comparison to, let's say, Apple, that they actually control all the devices, and it's not like Apple iOS is running in other vendors' hardware.